look at trying to make a video here about solving quadratic equations, okay? So let's see how this works out. All right, so we're going to talk about solving quadratic equations, and especially in light of the three different forms that we have for quadratic equations. We kind of have three different techniques or methods that we want to be comfortable with, all right? Let me move some things around. Here we go. So first off, if you have an equation in standard form, all right, like this, ax squared plus bx plus c equals 0, probably the easiest thing you could do would be to convert that equation into factored form and use the zero product property to solve. Now, we've done that a whole bunch, and I'm going to assume in this video that you're kind of familiar with doing that. All right? If that cannot be done, however, as is unfortunately common for a quadratic equation, you cannot factor it, your choices then become to either complete the square, and when you do that properly, you're converting the equation to what sometimes is called the perfect square form of the equation, and then it's fairly easy to solve with some algebra. I'll go through a little bit of an example of that a little bit later. That is something that you would consider doing if number one, the standard form does not factor, and a equals 1. If a does not equal 1, completing the square then becomes kind of tricky, and you might not want to do it. You might want to consider instead using the quadratic formula. So once again, the standard form has to be set equal to 0, and if it is, then you can use the quadratic formula, and this has to be memorized, folks. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And you can solve that directly by paying very careful attention to the order of operations, being careful with your arithmetic, and at the end you may even have to simplify the radical somewhat. So it is a process that, as I like to say, is fraught with peril. But the good thing about it is that it works every time for every single quadratic. So if you only had to learn one method of solving a quadratic, this would be it. Despite all its problems and places that you can make a mistake, it is the one and only method that always works. Okay? So if, however, your equation is in factored form to begin with, such as a times x minus m times x minus n equals 0. That's where the zero product property is really, really awesome, because the zero product property says that if two or more numbers can only have a product of 0 if at least one of them is 0. So if a times x minus m times x minus n equals 0, then either a equals 0, or x minus m equals 0, or x minus n equals 0. Either, any of those factors could be 0, and this equation would be true. However, it wouldn't be a quadratic if a equals 0. So we know that a does not equal 0. Therefore, we consider each of the remaining factors to be 0. And that's a pretty easy equation to solve. X minus m equals 0, or x minus n equals 0. Those are easy equations to solve. And you get your solutions pretty nicely. So by and large, the zero product property or factored form quadratics, those are considered the easiest ones to solve. Okay? If your equation is given to you in what is called the perfect square form, okay, and it might look something like this. This is also really, really similar to the vertex form of a parabola. So the perfect square form, vertex form, really the same thing, except that vertex form is about a function where this equals y, and perfect square form is really just solving an equation to find x. And this is really simple to do. You solve this by basic algebra, subtract x, divide by a. Don't forget to include the plus minus when you take the square root of both sides. Okay? And you'll get your solution that way. I'm going to show you something like that a little bit later here. All right? And so then, a final comment about all of these solutions. The solutions to a quadratic equation are called the roots of the equation. They're also called the zeros of the equation. We're going to stick with the word roots right here for now, but if you see the word zeros pop up anywhere, or if I happen to say that in class, it really means the same thing as the roots. All right? And if the roots, or zeros, are real numbers, then they are also the x-intercepts of the graph. Okay? So that's an important connection between solving the equations and the graphs of these parabolas. The next video is going to talk about the graphs of the parabolas. But I want to make one more final comment about the quadratic formula. All right? Quadratic formula. Number one, this, as I said, must be memorized. All right? And the solutions, if the solutions are real numbers, they are x-intercepts of the graph, even if they are irrational. Sometimes we get irrational numbers with these. Okay? So the same is true, though. For the quadratic formula, the answers that you get, if they are real numbers, are the x-intercepts of the graph. And there's a couple of other really useful things to know about the quadratic formula and this standard form equation. All right? In this equation here, the quantity b squared minus 4ac is called the discriminant. That is the thing that's underneath the radical up here, right? The square root of b squared minus 4ac. That part is called it's called the discriminant. All right. If this b squared minus 4ac is greater than 0, then there are going to be two unique real solutions to the equation. If it happens to equal 0, there are two. This seems weird, I know, but there are two identical real solutions. There are two solutions, but they're the same number. I know that sounds like I'm playing games with you, but that's how we think of it. If b squared minus 4ac is less than 0, there are two unique non-real solutions. All right? And finally, if b squared minus 4ac equals a perfect square, then this ax squared plus bx plus c could have been factored. All right? So you might have taken the hard way to solve the equation when you could have factored it. So maybe try this out first to see if you can factor it. Okay.